Is, what is it, 4 sections, 5 sections? 4
4
little sections. So that means it'll be over with in 3 weeks. 4 classes I get to teach, 1 for review, and then the test. So that's only 3 weeks, and this chapter will be over. The danger of that is it's an easy chapter, but if you don't keep up and you don't, do your homework and whatnot, obviously you're going to bomb it. Secondly, it's the last easy chapter because after this one is chapter 8, which is really, really hard. It is hard. A lot of people have difficulty working with percentages and money and formulas and word problems. Chapter 8 is just word problems because you can't write them any other way. And then after that is chapter 12, and a lot of people don't like chapter 12. It's statistics, and again, formulas, and working with tables and stuff. So this is the last nice chapter you're going to have, and it is a good chance of getting another good grade on a test. Last test, most people did okay. I was expecting better, but that's just me. This test is another one where you can get an easy A, and I'm serious about this. I think in chapter 4 I have more A's on the test than any other test I give. So if you work hard on this chapter, you will be rewarded. Trust me, it's just calculations. Now, the problem is this. I get to teach you, reteach you, and that's a danger right away. I have to reteach you stuff. So what happens there is you think you already know it, and therefore you start listening to me, and then you really don't learn it. So you've got to ignore everything I'm going over, assume that you know absolutely nothing, because I'm going to start teaching you 4th grade math in a weird way. Yeah.
That was good you said weird.
Yeah. It's 4th grade math if you were on a different planet. Seriously. If you were aliens with 3 fingers on each hand, you would be learning the math I'm teaching you today. Isn't that awesome? So, without further ado, section 4.1. Our system and early positional systems. What's sad is I have to teach you our system. Our system has a very fancy name if you want to talk about it. 2 things that we're going to be talking about throughout this entire chapter. 2 words. One is number. The other one is numeral. A lot of people interchange these. This is like equivalent and equal. A lot of people think of them exactly the same way. But in this case, you really have to keep the ideas separate. What is a number? Oh, come on. No, that's not a number. What does it mean to be a number? What does it mean to be 5?
The book saying
Oh, stop it. I don't want to hear what the book says. I don't care what the book says. I want to know what you think. What does 5 represent for you?
A number.
Yeah, but what does it represent? I'm trying to...
5 fingers.
5 fingers.
$5.
5 apples. 5 bananas.
$5.
A quantity. It answers how many. It answers the question, how many? Now, are there different ways of saying what 5 is? Well, yeah. Jay held up her hand and said 5 fingers, even though there's only 4 fingers and 1 thumb. But that's okay, we'll go with that.
I'm not being technical.
Hey! Is there other ways of designating 5?
Yes.
What is it?
Money.
You have $5 on the table, yeah. Or on a piece of paper you can write 5. Now, is this a number?
Yes.
No. It is a symbol that represents a number. So guess what a numeral is?
A symbol.
A symbol.
That represents a number. Like me.
A lot of people think that this thing that I've written on the board, this 5, is a number. It is not a number. It is technically a numeral that represents the value of 5. F-I-V-E would be a number. Writing 5 on the board like it is a numeral. So where F-I-V-E is literally the quantity, 5 as the symbol is the symbol that represents the quantity. I know it sounds a little weird, but we got to get used to it. Is this the only way to represent 5 on a piece of paper?
Tally mark.
Tally marks. We could do 1, 2, 3, 4 / 5. Roman numeral, which would be 5. Not the bar on top, not the bar on the bottom, just the V.
Why not? Why not the bars?
We'll talk about that when we start learning it. We could represent 5 this way.
What's that?
It's a bar.
Just a bar 5.
It's a specific culture. It's a specific culture. This is 5. Guess what that is?
Chinese.
Chinese.
I see them on the cookie thing.
This is 5. Kind of like tally marks in a way.
Arabic. So those are little ones at the
Definitely.
bottom.
They're little triangles. So all of these symbols represent 5, depending on where you are. Now this is where this chapter gets hard, because I'm going to be going between all of these different symbols, but they represent the same quantity. So just because it looks a little different doesn't mean that it actually is different. It's going to look different, but the value of it is going to be exactly the same. These are all equal to 5, every single one of them. Okay, so that's the difference between a number and a quantity. Now when we talk about our system, before we can have a system, you have to have symbols to represent these quantities. Now our symbols, you should know what they are. You better know what they are. They have symbols that are 1, 2, 3, 4, all the way up to 9, and we have to include 0. Now remember when I taught that first day about the real number system? You know, the counting numbers and the whole numbers and all that fun stuff. And I said 0 was a latecomer. There's a reason that we need 0, and you'll see it pretty quickly. But those are the symbols of our number system. That's it. On a keyboard, all you have is 1 through 9 and 0. To write 10, you'd have to write how many symbols? 2. So this is called the Hindu Arabic symbols.
These ours? You said these ours?
These are our symbols, but they're called the Hindu Arabic symbols. Now, why are they called Hindu Arabic?
That's where they came from?
That's where they came from. When I was growing up, when we learned these as our symbols, they were the Arabic symbols. But lately, I guess through history and research and going back in time and looking at documents, they found that the Hindus and the Arabic were symbols that got mixed together. Now, where's Arabic? Where's the Arabic people from? This Middle East someplace, right? Hindu? India. So the nice thing about the Arabic ones is they were in the middle of all trade. Africa, Europe, Far East, India, all that. Hindu also was a trade route through Southeast China, the Southeast Asia, and with the Arabic people. So they shared a lot of writing. Why would they need to write numbers?
To trade.
If you're trading, you're making money. If you're making money, you have to account for it. And governments are going to tax it. Yeah, they're going to tax it. So you need a number system to be able to count and to record and to send messages and stuff. So these Hindu Arabic symbols, they didn't look exactly like this, but they're really, really close. And as time went on, even letters have changed over the years. So there are Hindu Arabic symbols. Now, our numeric system is called a place value system. And the reason it's called a place value is every place in one of our numbers represents something different. For instance, if you write 4302, how do you read that? 4,302. Don't say the word and, that actually connotates a decimal. So one way of looking at this is it's read in English this way. But what I don't want to do is that. We'll do that in the last section. What I need to do for this one is I need to write this as 4 times 1,000 plus 3 times 100 plus, I want 10. So how many 10s are there?
2.
No.
None.
None. Remember, this 0 here is in what's place?
1.
One.
So 0.
That 0's in the 10s. So 0, I want it times 10, and I need to add on my 2 ones.
Or two ones.
Mr. Clark, could we just leave that out since we know that it's.
Oh, yeah, sure, you'll want to, but trust me, you don't want to. Remember, I'm reteaching you stuff. Don't assume you know
Okay.
anything. Yes, you can, but I'd rather you
No.
not. Why? Because to write 1,000, I'm going to change it into 10 cubed.
I know.
And then this one becomes 10 squared, which would be 100. And then this one becomes 10 to the first. And if I want, I could write 10 to the 0 here. What's 10 to the 0 equal? 1. So I don't have to write it, and I usually don't for that one. So this is what it means to expand a number. You break it apart into its place values. No scientific notation here. This is just base 10 numbers.
How do you know to start with 10 to the 3?
Because if we go the other way, this is 10 to the 0, 1, 2, 3.
So for all of them, that's how you would.
The best way to start is way over here to the right and move your way to the left. But most numbers are read from the left to the right, which is weird if you think about it. All right, so how would I expand? 1, 0, 5, 3, 1, 6. I highly suggest you start at the last number, so it becomes 6 plus
300.
times
1.
1 plus 10
Three.
1
squared
Times 3.
times 3 plus 10 cubed times 5 plus 10 to the 4th power. Oops, I put it outside, but it doesn't matter.
times 0.
Times 0 plus
There's 0 in that
10
place.
to the fifth.
10 to the 5th times 1. So it would be 1 times 10 to the 5th for this 1, 0 times 10 to the 4th for that 0, 5 times 10 to the 3rd for the 5, 3 times 10 squared, 1 times 10, and then finally just plain old 6. But it is best to go from the far right to the left and build your 10s as you go.
Times 10 of the whole number, right?
What's that?
You go to the left times 10. And
It's always going to be times 10, times 10, times 10, times 10, times 10. That's why the powers go up 1, 2, 3, 4, 5. Now there are shortcuts to this. For instance, this is a 6-digit number. And notice the power on the 10 is 5. It's always going to be 1 less than the number of digits you have. So if you have 8 digits, your first power is going to be 10 to the 7. So if you want to do that as a shortcut, that'd be fine. Alright, and that's just our number system. Our place value system. I guess my next question is this. Why does our place value system have 10s? Why not 5s? Why not 20? Why not 100?
10 are easier.
Why 10s though?
Even.
They got 10 fingers.
Oh, because we have 10 fingers. And we learned how to count on our
10
fingers. Now, I wonder, one reason that we count on our fingers is because we wear shoes.
We have
Are there cultures that do not wear shoes?
Yeah.
Yeah. Guess what their bases are when they don't wear shoes?
20.
20. And there are other cultures that only use one hand to count on, so their base would be 5. And if you're an alien that comes down from space with 3 fingers on each hand, their base is more than likely going to be
6.
6. So the only reason we chose 10 is because it becomes natural to us because we have 10 fingers. Now, if you were an alien with 3 fingers on each hand, base 10 would make absolutely no sense. So what I'm going to teach you here is how to become interpreters, be able to convert from one language into another and back. So you're going to become learning different languages in numbers. All right. So one of the older place value systems we didn't just magically come up with this base 10 numerology. We had to build it through history. And one of the first cultures that had a place value system, but did not have really good symbols, was Babylon. No, Babylonian. I have to spell phonetically. Babylonian. Where was Babylon? Come on, didn't anybody take history in here? Where? Israel? No.
Underwater.
It was not underwater, that was Atlantis.
Oh, Egypt. Is it Egypt?
It's in the Middle East. What country?
Greece.
Where?
Egypt.
No. There was a war there, and there's two rivers. One's called the Tigris, the other one the Euphrates. No one pays attention to
Iraq.
news either. Iraq. Babylon is now modern Iraq. And Baghdad is between the Tigris and the Euphrates. What happens with ancient cultures is they swarmed closer to rivers because rivers offered a way of irrigation to grow crops. So early civilizations would always grow up around a water source. Egypt always grew up along the Nile. So if you go up the Nile, there's cultures all the way to the left and to the right of the Nile, but nothing really too far away from it because they couldn't irrigate their crops and have large populations. So the Babylonians, that was a couple thousand years ago, about 3,000. There was no paper. Paper did not exist until about 2,000 years ago, maybe even a little shorter than that.
Made out of him.
Papyrus made out of the bark and whatnot. So the Babylonians came up with a neat way of writing things down. They used clay. So they had this clay tablets, and there's a bunch of famous ones. They have one that is a bridge between two different languages. I forget what the name of it is. I think it's in the book. And these clay tablets, they would have these long sticks, and the ends of the long sticks were triangles. So their language was based on a bunch of triangles pushed into clay, and they would come up with different symbols out of this one stick. So for numbers, they would have two symbols. One of them, of course, was this, and it represented what we think of as 1. And the other symbol, if they push the stick down twice to form this double triangle, they would go, at 90-degree angles, pushing it into the clay. This would represent 10. That's their numeral system. 2 symbols. One for 1 and the other one for 10. So if you were just going to use those 2 symbols, it would get really difficult quickly to write large numbers. For instance, 43 for us, for them they would write it as 4 10s and 3 1s. So they would write 10, 10, 10, 10. That would represent 40. And then they would do the 3 1s. And this would be their numeration for 43. Pretty easy, right?
Yeah.
Except for one problem. If I want to write 4,328 in Babylonian, that becomes tedious because you'd be sitting there all day making a bunch of 10s. So they came up with a place value system. Okay. Their place value system works this way. Let's get rid of all this. For example, they would write something like 1, 2, 3, 10, 1. How many place values are here? Nope. See, this was one place value.
Okay.
This represented 43. That one has 2 because I have 2 groups. So where we would just count how many numbers we had written, they're looking for grouped numbers. So the first group is a singular place value, and the second group is a second place value. So this is 2 place values. Now, just like ours, we would have the 1s, and then the 10s, and then the 100s. This one would be the 1s. This one became the 60s.
What? What?
Oh, no, don't worry about this right now, because you've already worked with this number system. You've worked with this since you were born. All right. Yeah, you have. So, the way I separate this is, here's the 1s place, here's the 60s place. How many 1s is this numeral talking about? That's a 10 and a 1, so this is 11. So there's 11 1s. It's 11 1s. And how many 60s are there? 3. Now, in our number system, if this was the tens, it would be 3 times 10 and 11 times 1. But this is not our system, this is Babylonian. So it's going to be 3 times 60 plus 11 times 1. Which is 11, yeah. And 3 times 60 is 180, and 180 plus 11? 191. So this number system up here, this 3 1s and 11, is equal to our number of 191. So for the Babylonians, this 311 bit is our 191. Not that bad, right? You just got to get used to a different place value. Okay. Let's make it worse.
Wait,
Wait, what?
yeah, we trying to soak that in.
Oh, no, there's no soaking in. There is no soaking. Let's make it longer. Why not?
Tell the short ones though.
3.
3 place values.
This one has 3 groups, therefore 3 place values. So this one way over here is the 1s. This one over here is the 60s. There are no 10s anymore, only in our system. And this one is going to be... shh, hold on. Ours goes 1, 10, 100, which is 10 squared. So theirs is going to go 1, 60.
360.
120.
Okay. Ours goes 1, 10 squared, 10 cubed, 10 to the 4th, and so forth and so on, right? So this is going 1, 60,
Under 20.
60 squared.
Oh.
Now, 60 squared is not 120 because that's 2 times 60. This is 60 squared, better known as 3,600. Don't call it 3,600 because that's going to mess you up with Mayan. You'll see in a second. We're getting there. So this is the 3,600 spot. This is the 60 spot. This is the 1 spot. How many are in the 60 square spot? 4. How many are in the 60 spot?
3.
No.
12.
12.
12.
That's a 10 with 2 1s. So that's 12. How many are in the 1 spot? That's 30. And that's 3. Okay. So now I've changed their symbols more into line with our symbols. Now we just have to go one more step and find its value. Now its value is going to be 4 times its place value, which is 60 squared, plus 12 times its place value, which is 60, plus the 1s, which is 33. And you type that in your magic calculator and you come up with a nice little answer. 153. 15,153 is the same thing as that black stuff way at the top. This is their language, this is our language. We're just being interpreters. Does it get worse? No. Does it stay exactly the same?
No.
Yes. For Babylonian, there is nothing different going on. There's some shortcuts. One little shortcut is this. If you have a number that looks like this.
What is that? Why is it boxed like that? He's showing you a shortcut.
I'm showing you a shortcut. What number is that?
That's 10.
29. What's wrong with this? Well, a lot of things. Number one, you could read the 20 really quick because it's just 2 symbols. But when you get to this line of triangles, it becomes difficult. You have to actually sit there and count. That's tedious, and your brain doesn't really understand. I want you to be able to look at it and understand what the number is. That's what's beautiful about our number system. You can look at it and actually just read it right away. Theirs, you actually have to sit and count. There is another way of writing 29. And the book doesn't cover this, but it makes your life a little bit easier in some cases. What I'm going to do is increase it to 30.
30, and then do the double.
And then I'm going to take away
1.
1. The takeaway symbol for Babylonian is this.
Yeah.
That whole symbol.
Peace.
You can use this or you don't have to use it. I'm just showing you a way of making things a little bit shorter.
Wait.
So this sign symbol right here means minus.
So big triangle, little triangle.
Big triangle, little triangle on top, that whole thing, both of them together represents minus, and we're going to subtract 1. So this becomes 30 minus 1, which is better known as 29. Now if I did 30 minus 2, that would be, and 30 minus 3 would be, and then after that I usually would just write it the other way. I wouldn't use the minus sign anymore. But it's a neat little shortcut if you want to use it.
I have a question.
Go for it.
Okay, right here when you did the example before you doing now.
Yeah.
Okay, how did you come to that answer to find it out?
Here,
Yeah.
I went 4 times 60 squared plus 12 times 60 plus 30.
So we have to times and multiply.
4 times, yeah, that's what it means, put numbers next to parentheses. Otherwise, you'd have to have a plus or a minus. If numbers are really, really close together, the operation is times. Powers have to happen first, by the way. Okay, what if I wrote this number down? Actually, let's go kind of backwards. I want to write 60 as a Babylonian number.
Come on.
Now, in our place value system is based on tens. The highest digit value we have is, what's the highest digit? 1 single digit is 9. It's 1 less than our base. 60 is their place value system, so you do not write 6 tens. So the way they wrote 60 was this. What's wrong?
That's a 1.
That's a 1. But here's the question, what place is it in? I don't know. So the Babylonians, since they did not have a symbol for 0, could not write numbers like 60, so that it was not ambiguous. So the way they wrote numbers was, they would say, oh, we collected this much taxes from this town. Now, if you knew how big the town was, you would know that this was either 1, which I doubt the town only collected 1 gold piece, 60. Now, it's a sizable town, so it wouldn't be 60. 3,600 sounds a little bit better. So they would read their numbers in context. They would understand the value of them depending on the words that were surrounding them. It's not the best way to do it because that could become very tricky, because that could represent 1, 60, 3,600, and so forth, and so on. So this is one thing bad about baby. They did not have a symbol for 0. They did not have a symbol for 0, so writing these types of numerals were very difficult. So I guess if they wanted to lose the ambiguity, they would write 6 tens, even though technically they shouldn't have. Okay, so what about this Babylonian numeral?
Yeah, too much fun with this.
How many place values?
4.
4. Let's see. There's this one out here. You always start to the far right. Never start on the far left. You come all the way to the far right and you say, what place value is this? It's always going to be the 1s. If you're in a positional place value system, that first one is the 1s. I could care less what the base is. The next one is the 60s. The next one is the 60 squares.
60 cubes.
And this one is going to be the 60 cubes. So let's see if we can do this one quickly. The first digit is 2. It's going to multiply 60 cubed plus 3 times 60 squared plus 4 times 60 plus 5. You type that in your calculator and you get a nice little number. Of course, I don't have a calculator, so I have no idea what this answer is. 4, 4, 3, 045. So this number represents 443,045. Not bad for only 4 place values. It takes 6 in ours. Okay, so that's Babylonian. Next culture. We'll come across the ocean and talk about the Mayans. Now, I gave you a hint where it is. Where's Maya?
Mayan is in Mexico.
Southern Mexico, Yucatan Peninsula, that area. Oh, you have a question. Go ahead.
Can you tell me how to type that into my keyboard?
Oh. Okay. This is 2, if you want, times 60 caret 3. And then just keep on going in that pattern.
Okay, 3
Plus
plus
3 times 60 caret 2. Plus 4 times 60 plus 5.
plus 4
Times 60
60
plus 5. And it equals.
plus 5. 4, 4, 3. Oh, 4, 5.
Yeah. Alright. Now, the Mayans was southern Mexico, Yucatan Peninsula. There was a famous movie a couple years back. Mel Gibson directed it. What was it?
I don't know.
Okay, what ancestor are those?
Mel Gibson movie a couple years ago, really bloody.
Passion of the Christ.
No,
No,
that was
it was,
way a few years ago.
Patriot.
That's on this side of the world.
The Patriot.
Apocalypto. Apocalypto.
Yeah, I saw that.
Apocalypto. That is based on the Mayan culture. Basically, I think it's the fall of the Mayan culture. Now, the Mayans, you also should have heard from the Mayans about their calendar ending in 2012, the end of the world, all that crap.
Temples and
Yeah. Well, the end of the world's coming, so don't worry about it. But of course, every year the end of the world is
Not.
coming, so don't worry about it. The Mayan culture had 2 symbols, kind of like the Babylonian. They used a dot that represented 1. They used a line that represented 5. Well, actually, they have a third symbol, and it's actually kind of important. Their third symbol was this.
Zero.
It's a 0.
Oh, they're a little bit smarter, huh?
They're a little bit smarter. They came up with a symbol for 0. Now, this is a picture of a basket, and inside the basket is absolutely nothing, which is the greatest representation of 0. So guess where the symbol for 0 came from?
A basket.
Basically, if you want to think of it that way.
Empty
A lot of cultures use the same type of symbol for 0. They use a void, an emptiness. Okay, so the Mayans had this number system, and if they wrote something like, you should be able to tell me what it's equal to.
13.
That's 13. It's 2 5s and 3 1s, so this becomes 13. That's a digit in their number system. It's a digit in their number system. Then we can get into weirder stuff like, what is this number? First off, before you even begin, Babylonian goes left to right. Mayan goes
Top and down.
up and down. Now, where's the smallest value going to be?
The top.
Oh, come on, we're talking about an ancient culture here. The
Well,
only thing at the top is the gods.
In the
So
middle.
they're going to have more worth, and at the bottom is us lowly humans, and we're less worth than the gods. So the bottom number is going to be your lowest place value, but as you go up, the place
26.
values increase. So how many place values are there? 2. And I'm going to put them on the side, so this and this are the place values. Down here is the 1s. Now, if you're down in Mexico, would you wear shoes?
Yes.
No. More than likely. And this would be the 20s. They actually use their fingers and toes to count. So they could count up to 20 pretty quickly. So this would be the 1s place, this would be the 20s place.
62. 46.
So how many 1s are there?
46.
6. So that'd be 6 times 1. How many 20s are there?
2.
So that'd be 2 times 20, which would be 46. Not a bad number system.
There's no,
We'll get there, Now, unlike Babylonian, this one has a symbol for 0, which makes it nice. So we could use the 0 to write numbers like this.
You mean we gotta really draw that basket?
Oh my gosh, yes.
Not like faces.
To be a mathematician, you have to also be an artist.
The middle one looks like Nick Jr.
The sad face. Okay, how many place values in this number system? 3. So the bottom one has a value of 0, and it happens to be sitting in what place value? So you go 0 times 1. Notice I do this differently than the Babylonian. I'm putting my answers off to the side rather than underneath. And that's just because of the way it's written. What's the value of the second place value?
12.
12. 2 1s and 2 5s. But that's going to get multiplied by
10. 20.
20. We never multiply by 10. Only if we're talking about our numbers. And the top value?
6.
And we're going to multiply that by?
20 squared.
You would think 20 squared, which is 400. But guess what they did? They screwed it up.
What's 40?
Nope. They put 360.
Oh, 360.
Why is it 360?
Yeah, now that's a good question. Why did they change it? Now, there's 2 branches of math in the Mayan culture. One branch was the traders, the common person, the layman. The layman would make that 400. So why would they officially write things this way in temples? Well, temples were priests, and priests kept track of what in ancient societies? No, they didn't keep track. Calendars. Very important to have a calendar because if you are growing crops, you want to know when to plant them and when to harvest them and know when the seasons are changing. So they force that to be 360 to make this a calendar. 360 days in a year. We know there's 365, but ancient cultures didn't get that accurate with the number of days in a year until about 700 years ago, maybe even less than that. So they base this on a calendar. This would be your years at the very top. The next one would be basically your months. And the last one would be your days. So this would be their calendar, and they could keep track of harvesting times. So they changed it to 360. Now, if there's a place value above that, it would be 360 times 20. It would just start back up with the multiply by 20 bit. It's a little weird. So, what's 6 times 360? We're going to add these all together. So 6 times 360, 12 times 20, 0 times 1 adds up or up to 2400. So this Mayan numeral represents 2400. But it's also a calendar. 6 months, 12 days. 6 years, 12 months, 0 days. If you want to think of it that way. Okay, how about something a little more elaborate? This is boring. I want to get. You have a calculator. Important. If you have dots on top of dots, how many place values is that?
2.
2, automatically, because dots can only be on top of lines, technically. So if I have dots on top of dots, these are 2 separate place values. This is not the number 3. This is a 2 in the ones place and a 1 in the 20s. Okay. So let's break it down one step at a time. This is 2 times 1. This is 1 times 20. This is 0 times 360. This is
20 squared.
no, here.
9
That's 9 times 360 times 20.
Okay, so when you keep the 360 and just put
Yeah, and then start multiplying by 20 again. This one up here would be
32 times 3.
32.
No, 17.
5, 10, 15, 16, 17. 17 times 360 times
20 squared.
20 squared.
Wow. Wait a minute.
What?
So we doing squared after the 360?
It's just that 360 throws things off. We have to keep the 360, but then we go back to multiplying by 20. So it's supposed to be 1, 20, 20 squared, 20 cubed, 20 to the 4th.
I thought you meant we started all the way over.
No. It's 360 times 20 squared, and 360 times 20.
20.
So, multiply this all mess together, and we end up with... Make sure you add them all up. A big number. It's going to be big.
So when you did 360 times 20 squared, you did basically 18 times 20 cubed.
If you want to think of it that way, sure. I'd rather you keep the 360 in there. For a grand total of... Oh, come on, John. It's just a couple.
251.
Yeah, 251, 282.
I'm because, and I'm not well,
Yeah,
I
you
probably
are.
am complaining.
Hold on.
I didn't get
That's not what I
the
got.
Babylonian thing yet, and now this is too much. for me.
But they're exactly the same. How many place values and what are the place values? What is it?
792,000.
It's-
5.
No, it's
251.
251.
828.
828.
No, 251 2
Can you go back on these things?
5.
1
1.
2
2.
8
8.
2
2. 2. 2,512,822. Ah.
Lordy.
Now, the interesting part. You have been using Babylonian numeral systems your entire life. Ever since you started counting a certain type of number. Can anybody tell me what that is?
1. What's what?
We've been using Babylonian. Where do we use Babylonian?
In the grocery store.
Nope. You use it every single day.
Oh, you said where?
You use it every single day. What is it?
A clock.
A clock. Clocks are based on Babylonian numerals.
Oh God.
Why? Because our clocks have seconds, they have minutes, and they have hours. Seconds would be your ones position. Minutes is how many minutes? How many seconds are in a minute? 60. And then how many minutes are in an hour? How many minutes are in an hour? 60. So that would be 60 seconds, so that would be 60 squared seconds.
And the word.
So when we talk about a second, that would be our ones. When we talk about minutes, that's 60 seconds. When we talk about hours, that's 60 seconds. So Babylonian is where we came up with clocks. Okay, now the next question. How many hours are in a day? Why 24? Why not 10? Why not 10 for the day and 10 for the night? That would be better for us, right? But the Egyptians, a long time ago, decided with a candle that there were 12 hours in the day, therefore there were 12 hours in the night, and they made the 24-hour
They
clock.
found it out with a candle.
So, the Egyptians gave us the 24-hour day, the Babylonians gave us seconds, minutes, and hours. Go ahead.
I can't get that answer over there.
We'll work on it later. After class, I'll help you. After class. Okay. I kind of lean into the next section with what I'm going to teach you next, but I'd rather teach it now than later because they really don't cover it well in the next section, so I'd rather do it now.
So 4-2.
No, this isn't 4-2, but it kind of leans a little bit towards 4-2. I want to convert back. Convert 68 into a Babylonian number. Our number is 68, but I want to write it as a Babylonian number. See, if you're a good interpreter, you can go from Spanish to English and English to Spanish. Good interpreters don't just go in one direction. They have to be able to go in both. So here is our numbers, our base 10 Hindu Arabic positional system, and I want to convert it into a Babylonian numeral.
Okay.
So how do I determine how to write it as a Babylonian numeral? What do I have to find out? Number one, how many place values is this number going to take up in a Babylonian system? 2. So you separate it into 2 places. The first one is going to be the ones. The next one is going to be the 60s. The second thing you ask is, how many 60s are in 68?
3. 1.
One.
Oh, well.
It's only one 60.
Where?
So you put a 1 up here. If you take the 60 away, how many are left?
8.
8. So to write this in Babylonian, I'm going to write 1 and 8. Oops. And this number here that I've written down at the bottom is 68.
Okay,
That's
what is
it
that?
right there.
What is what? This?
That's minus 1.
What's that
What is
mean?
the minus?
Minus. That's 10 minus 2,
Minus 2.
better known as
Okay, so
8.
it's 10 minus.
10 minus 2 is 8. I don't want to write 8 ones. It takes too long. But you can write 8 ones if you wish.
If I'm gonna do mine, I ain't gonna like 8.
Just make sure you count them out right. All right, let's make it worse.
Alright.
I ain't think forget no worse.
They can. Convert 47 to Mayan. When you do these conversions, actually the conversion works both ways. How many place values in their system is going to be the question you ask. And I'm going to say this throughout this entire chapter. How many place values in their system? Because I could care less about ours. That's ours. I could care less if there's 2. But I'm more concerned about how many positions does this take up in Mayan. Now, the Mayan place value system, the first one is the 1s, the next one is 20s, the next one is
360.
that one's way too big, right?
Yeah.
I want you to go way too big. That kind of indicates that you're on the right path. So you're asking now, how many 20s are in 47?
2.
2, because 2 times 20 is
40.
40. So there's 2 of them. How many are left over?
7.
So
Now, do not read that as 27, because that would be our number. This is 2 20s and 7 1s. To write this in Mayan, it's 2 and then 7. But it's definitely not read 27, because 27 is not equal to 47. This number here is equal to 47. They are equal. There are 2 different ways of writing it.
That bar is considered
5. So this is 5, 6, 7.
okay.
And then 1, 2. So there's 2 place values. The top one is the 20s. The bottom
That's
one is
the
the
only go on top of line.
1s.
Right.
What?
That's the only go on top of line.
Dots go on top of lines or by themselves. But you can't have dots on top of dots. It has to be 2 positions. All right, let's make it worse.
Oh, wait, Mr. Mom.
7.
The dots are 1.
Dots are 1s.
The top one is 20.
No. The top one is 2 20s.
And then
That's cool.
The bottom one is 7 1s.
the dots on top is 2.
2 20s because it's in the
20
second
place.
position.
Okay.
Yeah. All right, how about this one? Convert 4037 to Babylonian.
So it's gonna have 4 spots, right?
I don't know. That's our number system, not theirs. Their number system determines how many slots. So if we're in Babylonian, you start off with the 1s. The next one up for Babylonian is
60.
the 60s. The next one up is
60 squared.
better known as 3,600. The next one up is,
60 period.
do you think it's going to be too big?
Yes.
I think so, because 60 times this is going to be way bigger than 4032,
You know,
4037.
start at 6.
So, how many 3,600s are in 4,037?
1.
1. Now, what operation are you doing when I ask that question? Is that a subtraction?
Estimate. Elimination.
Okay, I have $20 and 5 friends. How much money can I give each of them?
Distribution.
Dividing. Division. So when I do this, it's actually 4,037 divided by 3,600 is 1 point something. But all I'm interested in is how many times does it go in. So you put a 1 up here. I'm going to do it by long division. 3,600, 4,037. Goes in once. You write down your 3,600. What do I do with these numbers?
Subtract.
Subtract them. What's left over?
437.
437?
Yep.
Now, there's one 3,600, but I have 437 units left
7
over.
times.
So I have to take that and divide it by 60. So I'm going to go 60 goes into 437. Only place values go on the outside. Numbers go on the inside. So 60 goes into 437? 7? 7 times 60 is?
420.
420. Subtract and you get
17.
17.
17.
So my
17 ones though.
17 1.
17 ones, right. So this 1 goes into the 3,600s. This 7 goes into the
17.
60s. This 17 goes into the
17.
ones. So how do I write that in Babylonian? Well, I need to write 1, 7, 10 minus 3, or 7. You could do 7 ones. 17. How do you want to write it?
2.
20 minus
3.
3. And this symbolism way down here at the bottom is equal to 4,037.
Too much.
It is awesome.
I ain't got enough legs already.
Got that.
Once you get used to this, it's not hard. You're first seeing it here and you're like, oh my gosh, it's really not that bad. You've been doing it your entire life, except you've only been doing it in base 10. I have shown you 2 different bases now, position systems, and you just have to learn how those rules kind of work. Shy.
Would you mind reading the number, the Babylonian number? That
This is
little-
1.
And what does that represent?
It represents 1/360.
Okay.
So this by itself has a value of 3,600.
Okay.
This one has a value of 7/60s, better known as 7 times 60. This one has a value of 17/1. So if you go 17 times 1, 7 times 60, 1 times 3,600, and add them all together,
4,000.
you're back to 4,037.
So that would be the answer right there.
Yeah, that's the answer. In Babylonian, it's equal to 4,037. How much time do I have? No, it's not. I got plenty of time, so I'm going to torture you some more. Convert. Let's make it a horribly ugly number. 47,059, and I want to convert it into a Mayan numeral. 47,059. And I want to convert it into a Mayan numeral. Before you start, you have to ask yourself, how many place values in Mayan? I could care less if there's 5 place values in our system. I don't care about ours. I care about somebody else's. So, to find out how many place values in Mayan, you start off with the 1s. The next one up is the 20s. The next one up is 360. I need to know their values, so I don't want 360 times 20. I need to know what it is.
7,200.
7,200. 7,200. And the next one?
It's too big.
But what is it? I'm just curious. 144,000. Right?
Yeah.
144,000. That's obviously way too big because it's bigger than 47,000, so we cross it off. When I convert from theirs to ours, there's no crossing off. I know exactly how many place values there are, I know what to do, and I get an answer. This one, you don't know what you're doing, so you go as far as you have to and back off one. Next question up, of course, is how many times does 7,200 go into that number? So you go 7,200 goes into 4,7,059. 6 times?
Yep.
6 times 7,200?
360 squared.
43.
What is it?
43,200.
43,200. Ugh. 43,200. And you subtract those, you get
38.59.
what?
38.59.
38.59. Now, where does the 6 go? Goes over the 7,200. Where's the 38.59 go?
In another box.
In another box, and it's going to get divided by
360.
360. So I'm going to go 360 goes into 38.59
10 times.
10 times, which gives you 3,600. Subtract and you get a grand total of 259?
Yeah, that's it.
Yeah, you that's it. Where's the 10 go?
Over the 360.
Over the 360. Where's the 259 go?
Do something.
You're going to divide it by
20.
20. So 20 goes into 259. How many times?
12 times.
12.
Yep.
12 times 20 is
240.
240. You subtract and you get.
19.
19.
Where's the 12 go?
Over the 20.
Where's the 19 go?
Over the 1.
And there we are. We're almost done.
Almost.
So all this is a bunch of division, subtraction, put it in a quotient up top, or the quotient up top and the remainder at the bottom. So when I write this in, what are we doing? Mayan?
Yes.
6. How do I write 6?
A bar, a dot and a bar.
A dot with a bar under it, there's 6. 10?
2 bars.
Now, I have to be really careful. The 2 bars can't be anywhere near this bar because I can have 3 bars in a row. So just give yourself a little space, 2 bars. Keep your bars really close together. Except for you, Jay. Really close together for you would be right on top of one another. Make sure you have a little space going on. 12,
2
Two
bars,
bars,
2
two
dots.
dots.
2 dots and 2 bars. And 19,
4 dots, 3 bars.
4 dots. And how many bars? 3. And there would be the Mayan numeral for 47,059. Isn't that crazy? Okay. Questions for you to do.
Wait.
Now that I've taught you all of this junk, I want you to answer this question.
Excuse me.
How you would do that?
Give me the value for this.
And what?
I don't know, you tell me.
Hours.
Hours, because that is
Not
theirs,
hours.
not ours.
What you mean, like?
What's it equal to?
Oh.
How much money would I be giving you
That's
if
what
I
I'm
gave you
saying.
this much money?
Okay.
Yeah, it would be a lot. I'll give you that. But what is it equal to? I don't know because, darn it,
I don't know.
a calculator. You should be getting 11,372.
I got 373.
373 or 372?
Oh, I bet you made one.
372.
Yeah, that's it.
So, how many place values?
3.
3. This one is going to be 3 times 3,600. This one is going to be
6,
8, 9
times
times
60.
60.
9 times 60. This one's going to be
32.
32. And if you multiply that all out, you get 11,372. Yay. Not that bad, right?
No, not really.
Try this one.
So the mess up. So really the mess up would be if you added in this form.
10 take away 1.
Convert 5,720 into a Mayan numeral.
Okay.
May I make a suggestion? Do not use commas in your numbers anymore. Just lose them. You don't need them. And technically in math, you're not supposed to write them anyway, so that's just for money. Regular math, commas are not necessary. So convert 5,720 into a Mayan numeral. Good luck. Always be division. So since we're converting to Mayan, you start off with the 1s, you work your way to the 20s, you move up to the 360s, and the next one is the 7,200. That one is way too big. The difference between these two is I know exactly what the place values are here. I really don't know what they are down here. That kind of gives you a hint that you're going to divide. If you already know how many place values, multiplication. If you don't, it's usually division. Okay, so how many 360s are in 5,720? Well, there's 15 of them. But if you do the long division, you get 15 goes into, not 15. 360 goes into 5720, and it goes in 15 times, which is
5,400.
5,400. You subtract and you get 320, and then 15 goes there, 320 gets divided by 20. 20 goes into 320,
16.
which is exactly,
320.
and has a remainder of,
0.
so you put a 16 here and a 0 there. How do you write 15?
3 lines.
1, 2, 3. How do you write,
A dot and 3
I'm sorry.
lines.
yeah, dot and 3 lines. And then
And
finally,
a basket.
you need the basket.
Yeah, that.
Okay. Now here's a small question. I could have designed this problem so the 0 was in the middle. How would I know a 0 was in the middle? You wouldn't have a remainder of 0 anymore, because that's what forced this one to be 0. So let me talk about how do we know 0's in the middle. How much time do I got?
None.
I got 5 minutes. We'll make up a problem real quick.
Don't do that. My calculator just died.
Thank God for solar calculators. Notice the one I wanted you to buy. Hmm. 3, 9. Convert 39657 to Babylonian. 39,567. 39,657 to a baby number. Babylonian. Is this going to be multiplication or division? Division, because we're converting into their system. It's only multiplication if we're converting back into ours. So, you start off, I'll give you the first part of it. How many place values? I have no idea. So you start off with the ones. The next one is 60s, because we're in Babylonian. Next one, 3,600. This number becomes dangerous because in Mayan it's 360, and if you start saying 3,600, you're going to lose a zero and you're going to be in Mayan when you should be in Babylonian. So be careful, call it 3,600 or 60 squared. The next one up is,
Too much.
it's not 7,200, it's 60 times this number, which is
72.
216,000, I think.
So
Yeah, I think this is a little bit too big, right? So we cross it off, and you do your division. Now, when you do your division, you're going to say, well, 3,600 goes into 3,9,657 how many times?
11.
11. And 11 times this number here is going to give you,
600.
what is it?
39,600.
39,600. And that leaves you with
57.
57. So the 11 goes up here. Where's the 57 go?
2 ones because it's 0.
Over the
Well,
one?
it's supposed to go into the 60s, but when you do 60 goes into 57, how many times does it go in?
0.
And that's why you put a 0 here. Be careful. I've seen people take that division and go, oh, you can't do it that way, and they switch it. And they put the 57 on the outside. The only number that should go on the outside is place values. No number should go out there other than a place value. So 60 goes into 57 0 times, so that leaves you still 57, and that becomes our
One.
ones. So this becomes 11. Ugh. 11, 0. How do you write 0 in Babylonian?
You leave it blank.
You don't. Leave a bigger gap. That'll indicate that you're missing a place value. And they did do this. So they gap it out a little bit, and then they write 57. 1, 2, 3, 4, 5, 6, minus 3. And that would be, and you can kind of see that there's a bigger gap in here than I would normally leave. So that would become a place value, an emptiness, a void. And that would equal 39,657.